Direct Connection is made by MPT to serve all of our diverse communities and is made possible by the generous support of our members. Thank you. Live from Maryland Public Television, this is Direct Connection with Jeff Salkin.
Hi, everybody. Thanks for tuning in for Direct Connection. It is a very cool thing that when mankind gets its first look at the most distant part of our solar system, the spacecraft that did it was designed, built, and operated by scientists here in Maryland. The New Horizons mission took nearly a decade to reach Pluto and has been sending back images for a few days now, opening up new questions about how our worlds came to be. Our guest tonight is the project scientist for New Horizons, Hal Weaver of the Johns Hopkins Applied Physics Laboratory. Dr. Weaver, thanks for being with us.
Hi, Jeff. Happy to be here.
How's the last week been for you?
Oh, unbelievable. It's just incredible. I mean, you know, after 9.5 years, this is a mission of delayed gratification in many respects, but the payoff was finally here. You know, on last Tuesday, flying just 7,800 miles above the surface of Pluto, you know, just capturing a whole new region of the solar system that has never been explored before. The objects in situ, the region called the Kuiper Belt.
It's hard to remember that prior to last week and a little bit before, all we knew about Pluto, when you would see a textbook, here's the planets, and you'd have Saturn and Jupiter. Pluto, it was just kind of a fuzzy dot. We didn't know much.
It was just a pixelated blob, even looking with the best telescopes from Earth. Hubble is fantastic, but from 3 billion miles away, it's hard to do anything. And so, you know, we got tired of looking at these little pixelated blobs. And, you know, this is the lesson we've learned from 50 years of interplanetary space flight, is that you have to go there if you really want to understand, you know, details about all of these objects in our solar system.
All right, we're going to get into all the photographs that you've released so far, but let's start with the big picture. This is kind of a look at Pluto as an object sitting in space. And for those who say that Pluto is no longer a planet, it's like some sort of dwarf planet, that looks to me like a planet. How do you see it?
Sure does. That's a planet. I mean, it's just screaming out at you. Has just a diversity of processes, geophysical processes occurring on it, and I think that you know, by the time we're finished with the New Horizons spacecraft observations of Pluto, I think that most people will be convinced that indeed, you know, it deserves to be called a planet.
Hear, hear. Next image, I think, is going to show part of. Now, this isn't Pluto anymore. This is it's almost like a twin. It's moon Charon.
It's actually a binary planet system. We call it binary dwarf planets. Charon is about half the size of Pluto. It was only discovered in 1978, by the way. Pluto was discovered in 1930. And this is just looking on the limb. You see this blown up region on the limb of Charon, where you see all these craters, and there's a mountain in a moat. That's what we call it in the upper left there. Even Charon was showing all of these diverse geophysical processes, and that was a real surprise to us.
There's apparently a Grand Canyon of sorts on Charon.
Yes, it is. I mean, it's 5 or 6 miles deep, bigger than things that we have on the Earth, and same thing on Pluto.
Next image is this is very cool. We were joking before about this being some cul-de-sac in your neighborhood in Baltimore County. But this is part of the most prominent feature on Pluto itself.
Yeah, that's right, the heart of Pluto, this heart-shaped region that's relatively, it's almost smooth, but it has these polygonal structures in it that we're still puzzling over, trying to figure out what they are. And then you see these bead-like structures accumulating in some places.
That's where the houses are being built on the cul-de-sacs.
Maybe it's being built up. But it's actually a region where we have an abundance of carbon monoxide ice in places as well. We've learned that recently.
And we'll run through the rest of the pictures and then talk about some other stuff. This is
incredible mountains. Rocky Mountain high. These are about 11,000 feet.
We were just looking at.
Exactly.
Right.
Just the diversity of things. These are, and we think they're ice mountains. They're not made of just your normal rock, but and they can't be made. The most abundant ices on the surfaces or on the surface of Pluto is molecular nitrogen ice and methane ice, but those are too weak to produce these mountains. So we think it's really water ice mountains. And water ice has actually never been detected directly on Pluto yet, but that's one of the things we're going after with the New Horizons, some of the New Horizons instruments.
So all by itself, we found water on Pluto is quite a headline.
Oh yes, absolutely. And there's a bunch on Sharon as well.
Conceivable way, we think water, you think life is, is so far out, so cold. Possible?
But underneath the surface, there may be a liquid layer. We think there's possibly some ammonia mixed with water, which is antifreeze, basically. It keeps it from freezing. There may be this liquid layer. There seems to have been some extra heat still captured within Pluto that hasn't been released, that's been a surprise to us. And, you have energy source, you have liquid, but you do have these extremely cold temperatures. I would be surprised if there was life there, but I wouldn't say it was out of the realm of possibility.
Wow. Let me remind our viewers, if you have a question about Pluto or the New Horizons mission or what is next over at APL, you can give us a call. We'll have the number up on the screen. You could also tweet your questions. Our Twitter address is @MPT News. I think we have one more image to put up, which was Pluto and its moon. And it just sort of looks like two balls there. But the interesting thing to me is how close they seem to be, and in terms of the way they orbit, it's almost like they're on a string.
Oh, it's like bolo balls, or it's like a dumbbell. The center of mass of Pluto and Charon is actually in between the two, outside of Pluto's surface. For our Earth-Moon system, the center of mass of that is well inside the surface of the Earth. But for Pluto, they're both revolving around this common center of mass. Which is in between the two.
Let's talk about the mission a little bit and how this came to be. Money's always tight at NASA, and the idea of exploring Pluto was something that was on the agenda, then it was off the agenda, and then it was on, but with as little money and as little power and as small a spacecraft as you guys could do.
Well, that's exactly right. Persistence. We had to have persistence because we've been trying to get a Pluto mission since the early 1990s. They would be accepted for a little while, then rejected, back and forth. But finally, in 2002, the National Academy of Sciences identified the exploration of Pluto in the Kuiper Belt as the highest scientific priority for planetary space exploration.
Well, let's stop there.
Yeah.
Why? What makes it so interesting?
Because this is a whole new region of the solar system that was only discovered in the early 1990s. Even though Pluto itself was discovered in 1930, it was sort of an oddball. Nobody could figure out how it fit in. But in the early 1990s, there a whole new bunch of discoveries of objects out in that region. The light bulbs went off and said Pluto is just another one of those. And this is a region called the Kuiper Belt. This is what we call the third zone of the solar system. The first zone is the terrestrial planet region, the relatively small rocky planets. You got Mercury, Earth, Venus, and Mars. Okay, that's the terrestrial planet region. You step a little bit farther out and you get the gas giants, Jupiter, Saturn, Uranus, and Neptune. And now, as you go past Neptune out into the rest of the solar system is called the Kuiper Belt. There's this relatively, it's like a donut-shaped region surrounding the giant planets where you have the leftovers from the formation of the solar system 4.6 billion years ago. And these objects, they're in all kinds of crazy orbits. Some of them are almost perpendicular to the plane of the orbits of the other planets in the solar system. And some of them are highly elongated. But it's a whole new region of the solar system. This is civilization's first step into that region of the solar system.
Is that why it's a little bit of a surprise that with all that stuff flying around, there were big sections of Pluto with no craters?
That's exactly right. We were expecting to see the surfaces, especially Charon, pummeled, just littered with craters, because it is like a shooting gallery out there. There's meteorites flying around for billions of years and striking the surface, and they would just stay there. But because you have these active geophysical processes going on both Pluto and Charon, it kind of wipes out those the signature of those impact events. And that's why some of the surfaces, some regions of both Pluto and Charon is called young, because you've had these processes taking place that have wiped away some of its history.
Let's grab a phone call. Prince William County, this is Jeff. Jeff, thanks for the call. Go ahead.
Yeah, I was just wondering if with this mission, were you able to detect better what the average temperature range is and atmosphere of Pluto is? Because I always read it's very, very cold, but nobody's ever said, how cold and stuff, I guess. So.
That was a great question, and that was absolutely one of the main objectives of the mission, was to map the temperature over the entire sunlit surface. We had more than 64,000 footprints, across the surface. We're just getting those data down now. It came from our infrared spectral imager. Most of the, at the subsolar point, where noon is on Pluto, for example, it's roughly only 50 degrees above absolute zero, minus 390 degrees Fahrenheit.
Well, chilly.
But the other interesting thing is, what is it on the night side? What is the temperature? We actually had an experiment. We flew past Pluto and flew through Pluto's shadow, looked back at the Earth, and looked back at Pluto with our radio beam, and we could measure the temperature of Pluto both around the equator and at the poles. And we're just analyzing those data now as well. And it's significantly colder than on the other side, but exactly what those temperature differences is going to tell us about the surface layers on Pluto. What kind of material was there? Whether it was how much was it crusty, regolith or solid.
I want to talk about the spacecraft, but let's take another phone call first. Baltimore City, this is Fred. Fred, thanks for the call. Go ahead.
Thank you for taking my call.
You bet.
I wondered how large Pluto is in relation to our moon.
Great question.
I know Charon's about half the size, and the other thing is I agree it should be a planet.
All right.
Fred's vote counts. Okay, so relative to our moon,
so
great question.
About 3/4 the size of Pluto's about 3/4 the diameter of our moon. So that was one of the reasons why people felt like it didn't deserve to be called a planet.
Okay, so the spacecraft, the actual device that you guys built in Howard County and stuck on a rocket and sent to the farthest end of wherever, maybe about the size of this table?
Exactly. Wow, this is a very good model for the spacecraft. It almost is this shape. It's funny. We had to miniaturize everything, make it as energy efficient as possible, and put it on the country's largest rocket, the Atlas V 550.
Not because it was so heavy, but because you needed so much speed.
We needed the energy to get all the way out to Pluto in a reasonable length of time. We left the Earth faster than any other spacecraft. We departed at more than 36,000 miles per hour. We crossed the orbit of the moon in only 9 hours. 9 hours, and it usually takes the astronauts, Apollo astronauts, 3 days. And so it was cool. We took off at 2 p.m. in the afternoon, 11 p.m., and we had a full moon. And I was out there looking at it and said, wow, the spacecraft has already gone by 13 months only to get to Jupiter's orbit. Mostly 5 years for the previous spacecraft. But still, Pluto is so far away, it's more than 30 times farther from the sun than the Earth is. So. Yeah.
And it's so far out there that the sunlight is so faint that you could have an army of solar cells and not get enough power. So
we
you
had
have a
nuclear power with plutonium-238. It was actually spare plutonium from the Cassini mission, the one that's around, has the orbiting Saturn right now, and has a half-life of about 76 years. But it generates it's actually hot. It's radioactive, but it's actually physically hot. That heats up thermocouples that then drives photovoltaic, energy. Provides the power.
It's a little dangerous, but this is the world's greatest battery. It's going to last with minimal decay for a long time.
Right. Yes, we could go on for another 20 years.
But that said, you didn't have enough power to run everything at once. Like you'd have to run the camera and then the transmitter.
That's true. We can only put on one transmitter at a time. At the same time, we're trying to run all of the instruments. As we're flying by Pluto, we're trying to squeeze in as much as we possibly can. So we're like turning on and off all of the instruments one after the other, and operating a couple of them simultaneously.
When we have a chance, if the control room still has the animated flyover video, that's pretty cool, and we ought to take a look at it again. The other point to make is that most of the data from the flyby, which is over, is still sitting on the spacecraft. It's not back here yet.
That's right. It's going to take a long time, roughly about a year, for us to downlink all of the data even though this is,
It's just like AOL dial-up?
Yeah, well, it's 1,000 bits per second, 1 kilobit per second, not megabits, not megabytes, but just kilobits. And
so we've gotten back so far is you had it set to send back a couple of compressed pictures.
Right. Yeah. We had what's called lossy compression. The scientists have been complaining about that. It's JPEG. The normal JPEG that you compress your images with. We use on the spacecraft as well and send those data back. But we will send everything down what we call losslessly compressed, so the full data quality will eventually be available to us, but it just takes a long time. We wanted to get at least a snapshot of some of our choicest observations, some of our choicest images down early.
Worcester County, let's talk to Mel. Mel, thanks for the call. Go ahead.
Yes. How are you doing today?
Good. How are you?
All right. I'm a little nervous.
What's your question?
The question is, are we able to tell how old Pluto is? Is it roughly the same age as our planet?
Great question. Thank you.
Yeah, good question. We do think that Pluto and Charon, they formed during a giant collision about 4.6 billion years ago, the same age that all of the other planets in the solar system formed. That happened to be the time when it was densest in the solar system, and that's the most likely time that it formed.
What happened about 10 days ago, 2 weeks ago? I don't know if we saw that expression, but you lost contact.
That was not a good day. Yeah. I was sitting in my, in my home here in, Pikesville, working on New Horizons, data, and I got a call from the principal investigator who was huffing and puffing, running to the Mission Operations Control Center at APL, saying that we'd lost contact with the spacecraft. This is only 10 days out from the big day, and this thing is 3 billion miles away. Space missions are they're risky.
Because if you hit anything at that speed.
Oh yeah, even a rice pellet blows a hole through the spacecraft at 30,000 miles an hour. It has to hit right in the right place. I mean, we will take little hits here and there, but so that was one potential thing. But we realized after analyzing that problem that probably wasn't the issue. We found out pretty quick. We diagnosed the things pretty quickly. We regained the spacecraft. Actually operated perfectly. We basically overloaded the computer, like having too many windows open on your computer at once, and we drove it into to reset itself.
Right,
it reset itself.
Error.
We switched to the other side, and but the spacecraft autonomously did this. I mean, it had to be programmed. There's no joysticking this thing. It had to autonomously take care of itself. It reoriented, went from one side over to the other, one electronic side. We have redundant systems. That's the value of doing that. And it turned the spacecraft around to point at the Earth, and 2 hours later, we were back up.
But with the delay, you can't tell it to reboot and expect to hear something in 5 minutes.
You turn on a flashlight at Pluto, it takes 4.5 hours for the light to reach the Earth. So that's the fastest you can communicate. It takes at least 4.5 hours. So if you're waiting to hear something back, you send something up and you're waiting to hear a reply back, that's 9 hours. And so that's 9 hours. We've already traveled many, many thousands of kilometers, miles, and so you can't joystick this thing. Everything has to be done.
And there was no way to orbit Pluto at the speed you're going. It was one shot. We're going to fly right by.
This is a once in a lifetime opportunity. We're tried to go. We hit the spot. Was the so-called aim point to within kilometers, and we hit over a 9.5-year mission. We got there within 1 minute of the predicted time. So it's that's the way Newtonian mechanics works. But
and I should say the images we're looking at. That's simulated based on a single picture.
No, that's real data that you're seeing. It's been exaggerated a little bit in the vertical extent. But those are real pictures.
But it's the same picture we saw before.
Right. You animate it to make it look cool.
And that's quite effective. Let's talk to Joseph in Washington. Joseph, thanks for the call. Go ahead.
Yes. First, all space advocates are inspired by you and your team. Thank you so much.
Thank you for that.
And could you describe the mission for the spacecraft now that you've passed Pluto? What are your options for further observations.
Thank you very much.
Yeah, thank you. So we're speeding away from Pluto now. In fact, the funny thing is we're already 5 astronomical units away from Pluto, so that's the same distance from Jupiter to the Sun. We're heading deeper.
And that's just a week.
That's just in 1 week. Yeah, 6 days. Because we're really tooling out of here. But we have we want to fly by another Kuiper Belt object, a different type of Kuiper Belt object, something that's a different family of Kuiper Belt object compared to Pluto and Pluto's, the other objects in the Pluto system. And we've already identified 2 potential flyby objects. We're still analyzing them. If we get approved by NASA for what's called an extended mission, we'll actually make a trajectory course maneuver in the fall to point to head us toward one or the other of those 2 objects. We'll make a choice in August between the 2, and then in the fall we'll make the burn that'll send us off to one or the other, and we'll send a proposal to NASA next spring, making the case for why it should be done, why NASA should devote the resources and the money to do it. And we really hope to have it. So we're not, New Horizons is not over yet. We hope to fly by another Kuiper Belt object roughly 3.5 years.
But the big thing is 95% of the data from last week is still sitting on it's not floppy drives.
Yes,
I guess,
that's right.
It's
a solid state drive. It's like your memory stick. In fact, the funny thing is, you go into memory stick, it's 8 gigabytes. That's one of our solid state recorders. Is 8 gigabytes.
Is that subject to solar radiation, whatever's flying around out there?
They have cosmic rays, which can occasionally reset the electronics. That happens, but we have automatic error detecting software that can fix single events, but sometimes you have double events.
Let me squeeze in another call.
Yes.
Gene in Fairfax. Gene, there you are. Thanks for the call. Go ahead. Hello, Gene. You're on.
Yes.
Yes, sir. Your question.
I was wondering why we could not have climbed closer to Pluto than we actually went by.
Thanks very much.
Yeah, that's a good question also. But when you think about the mission design in detail, when you fly really, really close, if you think about it, you're going such a high rate of speed, everything is changing so quickly. The angle at which you're trying to follow something is changing so quickly that you can't keep up with it. All your images would be streaked. So we actually picked the optimum distance, which was about 7,800 miles above Pluto's surface. So we have football field size resolution on our at the time of closest approach, which is pretty darn good. If you were flying over Manhattan, or over New York City with that kind of resolution, you could see the ponds in Central Park.
It still bugs me that you mentioned that your laptop, which is sitting over there, has a bunch of images that won't be publicly released until Friday. But that's a great tease for everybody who's interested in this stuff to tune in, to look at your Twitter feed, look at your website. You're pretty excited about it.
Friday afternoon, there's going to be a NASA press conference. It gets even better. That's all I can tell you. It's even more wonderful because the data keeps coming in and it'll continue to come in over the next year.
This is the sequel and many sequels coming up. So what have we learned about, forget Pluto for a second, planetary exploration? If you were to rebuild the spacecraft with what you know today, would you do anything different? And where do you go next?
Yeah, so what we're trying to do is learn the basic architecture of planetary system formation, including our solar system. So since we live within our solar system, we can actually make detailed in situ measurements of our own solar system. If we can understand how that works, that's going to help us to understand how other extrasolar planetary systems work. We already know that some of these extrasolar planetary systems have Kuiper Belt-like regions around them. Instead of looking at them through a telescope and from really far away, we actually are flying into one. And so that can give us some detailed information about exactly what kinds of objects are there, what is their physical and chemical makeup, and the physical structures. And that's what we're seeing in the images and the data returned back from the New Horizons mission.
Well, Dr. Weaver, congratulations on all this great work, and you and your team. Can't wait to see what comes out Friday, and we're glad you could squeeze us in tonight.
It's my pleasure.
Thank you very much. Thank you for joining us for Direct Connection. We're back Thursday with Your Money and Business, and then join us for Friday in State Circle and all the latest on Maryland politics. For all of us at MPT, thanks for watching and have a good night.
This program was made by MPT to serve all of our diverse communities.